Fusion Mobile, quality e-learning experience on the go.
Good day, welcome to Fusion Mobile e-learning class. My name is Bolaji. I'm here to teach you on mathematics as a subject, but the topic is federation. Before I proceed, what is federation? Federation is defined as the relationship that exists between two quantities. Example of quantity in federation is 1. Let H1 and H2, let H1 and H2 represent the hour by which a farmer works on a field in a given period of R1 and R2. Yes, let's consider a farmer working on a piece of land at hours of H1 and H2 and the period of R1 and R2. Now, this relationship shows two quantities, that is, the hours by which a farmer worked and the rate at which he was able to finish the work. So federation shows a relationship that exists between two quantities. Therefore, we can now say that H1 over H2 is equal to R1 over R2. That is, the hour at which the farmer worked with respect to the wages, which we can say wages, the rate. And also, the hours of 2 at which the farmer worked on the land is also equivalent to the wages of R2. Therefore, federation shows the relationship between two quantities, H1, H, and R. We have type of federations, and I will explain this type of federations to know the relationship that exists between quantities. Type of federation. Type of federation. Types of federation. We have direct federation. Direct federation. We have indirect federation. We have direct federation, indirect federation, joint federation, and partial federation. We have direct federations, indirect federation, joint federations, and partial federations. Let's take it one by one so as to understand the relationship that exists between two quantities. Number 1, direct federations. Direct federations explain relationships that exist between two quantities. Let's say X and Y. As X increases, Y also increases. As X increases, Y also increases. That is a direct federation. But there are symbols that shows the proportionality concept of these two relationships that exist between these two quantities. Direct federation shows that if X and Y are the quantities that want to show the relationship, therefore X is directly proportional to Y. That is, this symbol shows a direct proportionality. But we have to find the value of this proportionality. Without finding the value, we can't know the exact value or relationship that exists between X and Y. Therefore, X varies directly as y. This is the symbol for constant proportionality in direct variation. Let us consider an example pertaining to direct variation. I'd like to show you a chart that shows a direct variation. A direct variations chart that shows a direct variation. Charts that show a direct variations. We have tin of milk. We have cost. Now, we have 1, 2, 3, 4, 5. This is the tin of milk, and the cost price is this, where we have 40 naira, 80 naira, 100 naira, 120 naira, and 140 naira. Now, when you look at this chart, we say let's C be the cost price and let tin of milk be N. Therefore, as this tin milk increase, the cost price of the milk increases. Look at the board. The chart 1 shows one of tin milk costs 40 naira, the second one costs 80 naira, the third one costs 100 naira, the fourth one costs 120 naira, and the fifth one costs 140 naira. So it shows that there is a constant increase in the proportionality between these two quantities, tin of milk and their cost price. Therefore, we now said N, which is representing the tin of milk, is directly proportional to the cost price, which is the word C. So this example is giving us an illustration of constant proportionality. So also, I would like you to understand this chart very well so as to know the difference between two quantities when they varies directly towards each other. With this example, I know you have been convinced about direct proportionality concept of direct variations, and I believe by the time you solve these few questions, you will be able to understand direct variations. Thank you. I'm happy because you understood these direct variations. I believe as we go on, you will still have more ideas about this topic, direct variations. I want to give you another example on these direct variations if you still have a shady mindset. Given that y varies directly as x, given that y varies directly as x, given that y varies directly as x. Given that given that y varies directly as x, given that y varies directly as x, when x is equal to 3 and y is equal to 6, when x equal to 3 and y equal to 6, calculate y. Calculate y. Calculate y when x is equal to 7.5. Calculate y when x equal to 7.5. Solution. Solution. Y is directly proportional to x. This sign shows that it's a constant proportionality, a direct variation. Therefore, how do we remove this direct constant proportionality? Y is equal to kx, because k is representing constant proportionality. Therefore, kx is equal to y. To find k, divide both sides by x. So x over this, k is equal to y over x. K is equal to y over x. This is the law that connects y and x, that shows a constant proportionality, k, which represents this value. Therefore, once we have known that our k is equal to y over x, k, what is the value of this constant proportionality? As I told you earlier on, that this constant proportionality has a value that we must know, because it's showing the relationship between x and y. This k is equal to, what is our y? Our y is 6, and our x is 3. 6, 3 here 1, 3 here 2. K is equal to 2. So our constant proportionality is equal to 2. K is equal to 2. Then the question now said, calculate y when x equal to 7.5. Therefore, so far we have known the law that connects y and x in this quantity. We can substitute our value to find y. How do we now find this question? Let me solve this question so that we'll be able to understand the value of y. The value of y, because we don't know y is equal to, we said y is equal to kx. From the question, what is our value of k? Our k is equal to 2. Then what is the value of x? Is 7.5. Because they say calculate y when x equal to 7.5. And our y from the equation 1 that we solved that time was kx. Y is equal to 2 times 7.5, which will give us 15. So when x equal to 7.5, our y is equal to 15. You can see it increases. When x was 3, what was our y? Our y was 6. Then when x was 7.5, what is our y? Our y was 15. So this shows a clarity of a direct variation. As x increase, y also increase. I will give you an evaluation for you to solve so as to see the difference in relationship that exists when there is a direct variations between two quantities. Excellent. You got the question right. Let us move forward to direct variation. Indirect variation, sorry, we have moved from direct variation to indirect variation. Indirect variation. Indirect variation. Indirect variation. Earlier before, we showed that there is a constant proportionality between two quantities, we all know, because there is a variations between two quantities x and y in the first question we solved. Now this one, we want to show relationship that exists between two quantities when they are indirectly proportional to each other. Inverse variations, which is called indirect variations. You can call it inverse or indirect variations. Inverse and indirect are the same. Inverse variation means when quantity y increases, the other quantity decreases. Vice versa. That is, when y increases, x decreases. Let me give you this example. If y is inversely proportional to x, if y is inversely proportional to x, this sign is telling us that they are indirectly proportional because this is 1 over x. This constant proportionality is still there, but it is showing 1 over x. If y is inversely proportional to 1 over x, and our y is 7.5, our x is equal to 4. Find the equations that relate. The first thing was that we should find the equation that relates between x and y. How do we solve it? The equation is this. Solution. Y is inversely proportional to 1 over x is equal to k times 1 over x. Because we want to remove this constant proportionality, which is equal to k over x. Y is equal to k over x. Our k is equal to what? Yx. So the law that combine x and y is equal to k is equal to yx. That's the equations that connect y and x. Now, the next thing that we have to do is that they said find y when x is equal to 12. Find y when x equal to 12. Find y when x equal to 12. Find y when x equal to 12. Good. Y is equal to k over x. What is the value of our k? Our k is yx, and our y is 7.5. Then our x is 4. 7.5 times 4 is equal to 30. The law that combine y and x, k is equal to y over x. But our k, the constant proportionality in this question, is 30. Is 30, that's our constant proportionality concept between y and x in terms of inverse variation or indirect variations. So inverse variation and indirect variation are the same. So if you hear any questions that involve inverse variations and indirect variations, they are the same. Therefore, how do we now find y? To find y is equal to k over x from our equation. Y is equal to, what is our k? 30. And what is our x? 12. So y is equal to 30 over 12, which is equal to, you can cut it, reduce it to the lowest term. 2 here we have 15. 2 here we have what? We have 6. We have 3 here we have 5. 3 here we have 2. So 5 over 2 is our y. You discover that when x increases to 12, our y was 5 over 2, which is 2.5. Therefore, y, as y decreases, x increases. Look at here, y 7.5 was 7.5, x was 4. Then when x was 12, what happened to y? Y still reduced to 2.5. So this law, these inverse variations, connote, expatiate, and it enables us to understand that between two quantities x and y, it results into what? Indirect variations. As y increases, x decreases. As x increases, y decreases. I would like you to do these evaluations so as to know the difference between inverse variations and direct variations. Know fully well that inverse variations and direct variations are the same. Wow, the answer to the questions was absolutely right. Now, let us take this another type of variations, so as to know how far we understood this topic. And it's called joint variation. Joint variation. Joint variation means when we have two or more quantities that varies to each other, two or more quantities which are involved in the relations that occur many times. Two or more quantities, because in direct and inverse variations, we only consider two quantities. But in joint variations, we consider two or more quantities that relationship occur between them. Example of joint variations. Example is if y varies directly as d and inversely as the square of x. If y varies directly as d and inversely as the square of x, and d is equal to 30 when x is equal to 24 and y is equal to 1/18, find the law that connects them. Together, find the law that connects them together, and also find y when d is equal to 5 and x is equal to 2. Now, this is the questions that we have to solve. We say if y varies directly as d and inversely as the square of x. Now, solution to this question. The solution to this question is, I want you to focus on these questions because it involves three quantities. We have y quantity, d quantity, and x quantity. Therefore, y is directly, let us first consider direct proportional, is direct proportional to d, and inversely proportional, that is inversely as the square of x. This x value as the square of x. So this is the interpretation of the questions. This is directly proportional to d and inversely as the square of x. Therefore, y is equal to k. We want to remove this constant proportionality. Is equal to a over d equal to kd over x squared. Y is equal to kd over x squared. Because of this constant proportionality sign, symbol must be removed. Therefore, this is the law that connects them together. But we need to find our k. Our k is equal to kd equal to, you cross multiply to find this. This is over 1. We have kd is equal to yx squared. To find k, divide both sides by d. Kd over k over d is equal to ys squared over d. D cancel d. We have k is equal to ys squared over d. yx squared over d. K is equal to yx squared over d. K is equal to yx squared over d. So this is the law that connects yx squared and d. We have three quantities in this aspect because it's called joint federation. So the next question now said we should find y from this question. How do we find y? We make y the subject of the formula. We make y the subject of the formula because the question says find y when d equal to 5 and x equal to 2. So for uniformity, we divide this one over 1. Then yx squared is equal to kd. Divide both sides by s squared. Yx squared over y equal to kd over y. Over s squared, s squared cancels s squared. We now have y equal to kd over x squared. So we have y is equal to kd over x squared. That's the value of y. But remember, our constant proportionality, we have to know the value before we substitute the value of y. Therefore, k is equal to, what is the value of our y? From the first question, our y is 1 over 18 times, what is our s? Our x is 24, that is times 24 squared over, what is our d? Our d is 30. Now, the 24 squared times 1 over 18 times 30, the answer to this question is 30k equal to 1 over 18 times 24 squared. 30k, which is the value of k. So here we said divide both sides by 30. Divide both sides by 30 over 30 equal to 1 over 18 times 24 square over 30. K is equal to 16 over 15. So our value of k is 16 over 15. That is, when we say 1 over 18, 24 square, using our calculator, 24 square times 1 over 18, divided by 30 will give us 16 over 15. That's the law that connects both our y, x, and d quantity. Now, how do we find y when d is equal to 5? Find y when d equal to 5 and x equal to 2. Find y when d equal to 5 and x equal to 2. Our k is equal to 16 over 15. You now say find y when d equal to 5. So when d, to find y when d is equal to 5, our x is equal to 2. Find d when, find y is question mark. Therefore, y equal to k d over x squared, which is equal to, what is our k? Our k is 16 over 15 times, what is our d? Our d is 5 over, what is our x? Our x is 2 squared. Y is equal to 5 here 1, 5 here 3. 16 over 3 all over 4. 16 over 3 all over 4, which is equal to 16 over 3 times 1 over 4, which is equal to 16 over 12. 16 over 12, which is divisible. 4 here, 4, 4 here, 3. Therefore, y is equal to 4 over 3. So, we discovered that the relationship between y and x and d quantity is a joint variations. That is, two or more quantities that are in relationships is called joint variations. When you look at the equation we solved, we discovered that their relationship was that y is equal to kd over s squared, because k, which is the constant proportionality, shows the relationship between d, y, and s squared. And they now say we should now find y when our d is 5, when our x is 2. Then, therefore, we apply the formula because we make y the subject of the formula in which you got this equation, which is equal to y equal to kd over s squared. Substitute the value of k that we got, which is 16 over 15, times 5. Our d is 5. Then all over s squared. X is 2, so 2 squared. We now have y equal to 16 over 3 divided by 4. Using this formula, we have 16 over 3 times 1 over 4, which is equal to 16 times 1, 16, 3 times 4, 12. 16 over 12. 4 here 4, 4 here 3. Our y is equal to 4 over 3. I believe you have gotten and understood these joint variations. I would like to give you an evaluation to solve so as to know and test our knowledge and how we can continue in this topic. Partial variations is the next, but I will not give you too much of note on these partial variations because as we advance on, we are still going to talk more about these variations. But for partial variations, I would like to give you a few definitions of these partial variations. Partial variations consist of two or more parts of quantities added together. One part may be constant, while the other can vary either directly or indirectly. Either directly or indirectly. So partial variation is telling us the quantities that happens in terms of their relationship. One may be constant, one may be directly. One may be either directly or indirectly or jointed. I believe you have understood the topic variations. You have understood the subtopic direct variations, inverse or indirect variations, joint variations, and also this partial variation in which I have explained. As we proceed, I will still throw you more light on these partial variations. Thank you. But before we go, I would like you to solve these questions so that we can know how legible we can solve questions ahead of us concerning variations.